Hello, this video is just to help you with a couple of the questions so you can complete them all. So we're going to do question 3 first. So I'm looking at question 3. You have to first decide if it's linear or if it's absolute. So this is linear because there's no absolute value. You have to first set this so that the y is by itself. So I would add the 2 over. I would add this 2 over. So now I know my m is 5 over 1. My b is equal to 2. So first thing, you plot those points. So up 2, because this right here would be 0, 2. And my slope is 5 over 1, so I can go up 5, 1, 2, 3, 4, 5 over 1. Or else I could go down 5, 1, 2, 3, 4, 5 over left 1. Then I have to look here. I have to think, is it solid or is it dotted? Because there's a line, that means this is going to be solid. Just like when we're in one-dimensional, that would be a closed circle. Now when in two-dimensional, that means a solid line. And then I have to look at this. Is this shaded above? Y is less than or below? So if it's y is less than, I have to look below the line and shade below the line. Now sometimes when the line is super steep like this, people can get confused because the fact that it doesn't look like above or below. You have to try to think, if you were to move this line at a different slope, where would below be? Sometimes that might help you. If this is too steep and you're not sure what below is, take the line, put your pencil on it, and try to move it so it's not so steep, and think, where would below be? So that would be for your y equals mx plus b. Now we have ones like 6. We're going to do question 6. Same type of thing. We have to get this y by itself. However, I see this, so I know that that's going to be absolute value. First thing I have to do is subtract my 5. So my new equation would be y is less than or equal to. This does not get touched. You do not touch that absolute value. These are two of my like terms, minus 3. So now I know my vertex, because I'm going to be moving left 1. So this is review from last week, and down 3. So my vertex is left 1, down 3. Now again, you can either graph this with the slope, the a value, or plug this into your graphing calculator. Just a little review for the graphing calculator. Y equals, and you're going to type in your absolute value, so math button, and then you go in num, absolute. X value is right here next to the alpha. X plus 1, you have to arrow over, minus 3. You have to get to that table part, so that means you have to push the blue button first. And we know our vertex is negative 1, negative 3. So I'm going to go past that, and here are my points that I could plot. You need to have at least 5 points, so 2 on each side. So again, I look, is this solid or dotted? This is going to be solid like a rock. Make sure you extend your lines. Make sure you extend your lines. You should be taking over the whole graph here. And then I look, is this above or below? So y is less than, so again, that's going to be below the line. So it's going to be below this whole thing. And you do that for all the graphs. You go through and look for either y equals mx plus b, or you go through and look for the vertex and the a value using graphing calculator. Backside. So it tells you 3 things I want you to do. First, determine if it's linear or absolute. So we're going to do 10 first. So a, since there's a v here, this is absolute value. If it's absolute, you have to look for the vertex and the a value. So if I'm looking at this vertex, this one's counted by 2, so be careful when you're going through these graphs. So this vertex would actually be over 3, 0. So my vertex is going to be a 3, 0. And my a value, we start at that vertex, and we have to go to the right. Okay, it's always the first point on the right. So I'm going to go here. So once I have my 2 points, that a value is kind of like slope. Remember, I'm counted by 2. Then I'm going up 2, so this would be a 2 right here. And I'm going 1, and then this is over 2, so that's 3 plus 2 would be 5. So my a value here is going to be 2/5. Now looking at this, question 10 and question 16 are probably going to be the hardest to find the a value, but besides that, I think you guys are going to have a golden spot. So now you have to approximate your equation. So when I write this, I'm going to write a space. I have my y, and now I know my a value, so I have my 2/5, my absolute value, x, absolute value. Now I look at my vertex. Okay, so my vertex should go with my x. That one's always opposite, so this would be minus 3. If you want to write that plus here, you can. If you're like, I can't remember where you're getting this from, remember it's from this equation right here. Look back at 2.7 to help you figure out where those numbers go if you need to. Now I have to figure out the approximate inequality. So first thing I'm looking is the shading. So is it shaded above the line or is it shaded below the line? So this is shaded below, so I'm going to have a less than shaded below. Then I look at the line. Is it solid or dotted? Well, this is dotted, so there's no line here. So again, looking at the shading and then looking at the line. So that would be if I have a absolute value. Let's say if I had a line. Let's do this one down here. So here, this is linear. So I'm going to first write linear. Now I have to look for my mx plus b. So my b here is right here. So that b is going to be 0, -2. My a value, I'm going to pick this point and this point. Or my m value, sorry. So my rise is 1, 2. My run is 1, 2, 3. So my m is 2 over -3. Notice I'll make sure that I'm labeling it m and not a because this is linear. So again, I'm going to leave my space. And it's m x plus b. Okay, that's the lines. Now I look, is it shaded above or below? So it's shaded above. It's above that line, so that means y is greater than. And then I'm thinking, is it solid or dotted? So this is solid, so it's going to have an or equals 2. And there you go. You got the rest in the bag, and I'll be here the next day to help you out with it. Have a grand and wonderful day.